So I titled this presentation, Rethinking State in Angular Applications, for a few reasons. I'd like us to take a look at the state in Angular, what we currently teach, how people are handling things, and is state important or not in general, right? But before we go there, first, some of you know me already. I'm Okrushko. I work at a Firebase at Google. I'm also part of the NGXS core team. I organize Angular Toronto, which has actually been pretty successful for the last year. I took it over. And I'm part of the pretty smart group of folks at In-Depth of Dev. It's formerly Angular In-Depth, so where we chat and discuss a lot of things as well. All right, so state. Probably many of you know this famous quote from our leader Sundar that synchronizing state within application and backends is one of the most complex tasks that developers have to solve. Well, actually, I'm not sure he actually said that, but I'm sure he thought about it multiple times. So there you go. So what is this state? What is the state, and what do we need to manage? So what is the state? There are multiple ways to split it up. I've seen different ways. Actually, one of them, Victor Sufkin actually popularized. This is somewhat based on that as well. So we have multiple types of the state in the application. We have server backend state. This is the state that, is the source of truth for us. This is the one that we get from the web app and talk to this. And again, I'm covering these types of state. I'm sure you know all of them already, but I just wanted to bring us all onto the same page. And when we talk about state, we think in the same kind of terms. And there are multiple types of state on the web app: persisted, URL, client state, and local UI state, for example. There are more, but I'll just cover these in this presentation. So let's look at each one of them. The persistent state is the state that we call our backends, and we get the snapshot of the data. This is what our APIs return, right? So this is something like JSON that we get from the backend, and we also persisted back to the backends, hence the persistent state. URL state is an interesting one. It's one of the most obvious ones, but frequently overlooked. It's the state of the URL. Sometimes also a router state is included in this, but it frequently is the source of truth for the application. When user navigates to this one, it sets the tone or sets the scene for the entire application, right? Then we have a client state, something that is not persisted to the backend, but is important within the scope of the entire application. So for example, here, sign-in method tab is open, right? And it's important because it sets the stage for this page, what request's going to go, what we're going to display. So client state is important, and it's not persisted to the backend. And then the final one is the most simple unit of state. It's a local UI state. For example, this enabled button, right? It's now disabled, but component itself doesn't care what it's used. All it cares about is how input it was, what input it got, and how it needs to display itself. It's completely removed out of the context of this application. All it needs to know that, hey, right now when somebody tells me I'm disabled, I'll be shown in the disabled state. Somebody clicks on me, I'll push the output and notify somebody that I'm enabled now. But it has no clue how that would react, how the application would react. Would the data be persisted to the backend or not? Has no clue, so it's local UI state. So those are four quite important types of the states that I think when people start thinking in these terms, structuring the state of the application becomes a lot more straightforward, or at least we can now come with some of the patterns. Okay, so those are the states. And actually, that quote from Sundar that he never said is what I mean here. So synchronizing all of these is truly the most complex tasks that we have to solve. And interestingly enough, this is very frequently overlooked. So a well-known fact is that Angular is an opinionated framework, right? But is it though, right? So yes, it's true, we have a way of setting up and saying, okay, these are the forms you can use, these are the router that we provide, and they kind of all work together. That's great. But I think within Angular ecosystem, we're missing this one opinion on how we would manage the state in the applications. And it actually leads to most of the errors and issues within any Angular application. It's not the form usage that you use the API in the wrong way, right? So those are like easy ones. How we get the state together, how we manage all of it, these are the hard parts that are frequently overlooked. Okay, so we're gonna look at some of these examples, and we're gonna build up the state narrative, this through one of the applications. It's fairly straightforward application. It would be consisting of like 3 pages. We would have, like a product list page where it just displays the list of products. It would be, once you click on one of the products, it would be a product details page. So it brings some additional information, price, description, things like that. Here you can also like add it to the cart and stuff like that. And the final page is the cart content page, cart details page. This is once you add the products and you click on your cart icon, for example. This is where you get to see what you have and then you basically purchase. And this is not a tour of heroes. This is a little bit closer to a minimal functional application that people would actually be building in their day-to-day life. And I understand there are different types of applications that Angulars use. There could be the type of application where the entire data just flows down and there's no much interactivity. That's fine as well. But if you get into the functional applications, these are pretty much as basic as it gets, yet I'll try to display some of the concepts and some of the things that I think we should be thinking about when working with Angular. All right, so we'll start with one component, and we'll start with the cart icon component. This cart icon component has a data. It needs to display how many items there are in the cart. So let's take a look at this component. Well, here's our simple implementation of the cart item component. It has this cart items count property. Once you have a property, congratulations, you have a state, right? And there's multiple ways we can set this cart items count. We can set it, for example, through input, right? That'll be a more local state. Or we can set it differently. We can typically, so the contents of the cart is frequently persisted to the backend. When we know that we need to interact with the backend, we know right away that we need to do something with services. So here's another example how we could have received this data. We could have had a cart service that has the cart product, and we call it, we get those cart items, and then we'll reduce it to just a count. Here's, for example, the simple implementation of that service. What it does, internally, it calls the HTTP client, get, it returns this observable with cart items. And those cart items is basically just like a product ID and the quantity, right? So we can reduce it to a single count. And this is what's known as a stateless service. This is also what's known as a pool-based approach. Why is it a pool-based approach? Because every time we need the data, we need to call that method, we need to pull that data out and use it. So this is pretty much where we stop at, for example, Angular I/O tutorials. And this is pretty much where we stop. I'm actually leading instructing the course right now, Angular 101 and Angular 201 internally at Google today. I just had this 1 hour to do this presentation. But this is pretty much where we end, right? This is pretty much what we teach. This is pretty much where people have to figure out on their own what to do with it next. Great. So now we have a cart icon that can get the data. But the thing is, we have another component that also needs this data. Let's look at the structure of this page. So we have our cart icon here, right? And it's part of this header. So I'll just want to see how our components are structured. So here's the header. Then we have multiple cart product. We have for math book, for sheet, right? For every product that's in the cart, it would display this component. And all those components are in a cart page. So how do we get to the cart page? Well, we have a constant header, but then we also have a router outlet that takes care of multiple pages that we have, all three of them. And all of that is basically in a single app component, right? So this is our structure of this particular page, this particular view. Let's split it up into the tree view a little bit, so it's a little bit easier to see what I mean. So we have app, header, router, so basically the same view, but in a tree of components view. So cart icon needs the data about the items that are in the cart, but also cart page needs the data. So how can we approach this? Well, one of the approaches we can do is have cart service provide the data to the app, the first component that they have in common. And that, here's your cart items. And now we can push that through the inputs further down to the pages. But most of you would realize right away that this is quite not the appropriate way to do it. Why is it not a good approach? Anybody can answer quickly? Few answers, one answer, two answers. Is it good? Is it bad? Is it a viable approach? Yes, right?
Eventually, everything ends up in the app component.
Exactly. So everything's in the app component. Now we have header and router. They're just passing this data because they just have to pass the data down. They have no interest of this. We have to test it. Now, if we're adding another item that needs this data, we have to change all the parents, in the tree to get that. Moving components around would be a nightmare. So there are multiple reasons. Even the optimizations that we take, like on push change detection, this would trigger every input possible. So there's no point of on push at all. So it's bad for so many reasons, right? So, however, if we had a push-based approach that we had before with it, where it was stateless, right? So we're getting cart service back to cart icon and to cart page. Now, each one of them would be making HTTP requests, right? Do we want to do this, right? We probably don't, because we're basically getting the same data, and we don't want each one of them be calling this and pulling this data. So how do we solve this problem? Well, we solve it with multicasting. It's one way to solve this problem. It's with multicasting. So now we would have a property that says cart items $, which is an observable, and we would share replay the call. So now both cart icon and this page would get the data once, and it's no problem. So now in the component, instead of calling the cart service, this method, the get cart products method, I would remove that, and instead I'll use this reactive property. So what happens is now we transform the cart item component to a reactive approach. So now it's a push-based approach. So now whenever the cart item is ready, it will be pushed into this cart icon component. And what's interesting is this cart icon component doesn't know or doesn't care if it continues to change. It will just listen and update those, react accordingly. So this is a push-based approach. So that's great. We have that now. However, this assumes that our cart items never change, right? So basically we query it once and we use it forever. It becomes the same data all over, and reuse it, right? The same data. This is not how we do it in this application, because this application has many things they can do. For example, you can remove, you can purchase items, you can remove all, or even in the cart, in the product details, you can add to cart. All of that changes the state. All of these change the cart items that we have and that we know within this application, right? So the previous approach obviously doesn't work already. So what is the typical solution for this? One of the approach that community overall came up with is this behavior service with the behavior subject, or service with a subject. There are many names to it. There's observable service, or a reactive service, many other names. But in a nutshell, they're all based on the same idea. You have some kind of reactive state within it, and here behavior subject is a container of that state. Then it exposes that state through an observable. Here it's a cart item, for example. It exposes it as an observable because we don't want to users to push anything into it, so it encapsulates the data. And now all the methods that I have, like here, add product, they do not return anything to the caller. You see there, they do the void. So they do not return anything to the caller, but they act as messages or events into the system, right? So we say, hey, I want to add the product. And they would internally call the HTTP call. It would do added. And then, when it's added, it would subscribe to that and push this new value into this subject. So now all of those add or whatever becomes signals. And how does our component change? Well, now we're still listening for this cart items dollar, which is a reactive property of the service. And now we tell that we really want to get this product. So we send a message, our intention to start listening for this, basically, get cart products. So this is one of the first indirection that gets introduced, right? So we're listening for one thing, but we're requesting it the other way. So this is the first indirection that's introduced. And what's interesting, this solution works quite well. It works for many, and many are happy with this. But even this solution has its downsides other than perceived complexity. So what are the downsides of such an approach? The downsides is frequently overlooked. It's the race conditions. So when we, for example, click the first add click, for example, we have a very excited user that wants to add items to the cart, right? Clicks multiple times at the same time. So the first click is triggered, and then the second click is triggered. But the network requests are interesting because the second one could succeed before the first one, right? And we have our race conditions. And the way we had structured our behavior service with the behavior subject right now, every call is basically sends the new request in parallel. So how do we control this? Well, within, again, the community, there is a way to do it, and the way to do it is encapsulating the side effects. So the side effects or effects, they control those race conditions. And I actually forgot to ask at the beginning, how many of you are familiar with NGXS? How many of you are familiar with NGXS Store? And how many of you are familiar with the newest addition of to NGXS, which is called Component Store? So Component Store, it actually is designed to implement an opinionated and prescriptive behavior, a service with the behavior subject. So it's a replacing for this. And the way it was designed is also interesting. So we broke apart the tasks that we typically need to do with the service and the state that it contains. And those tasks are, again, fairly straightforward. You should be able to read the state. You should be able to write the state. And the last one is you should be handle those side effects. And with this prescriptive way, I think we have very good solutions. But let's look quickly take a look at those APIs. So for the read, we can select things. For the write, we can updater. We have an updater method. And for side effects, we have an effect. Let's take a look at the example. We will basically rewrite this card service into the card component. Actually, we won't do just that. Card service, we are pushing it back, so it would be completely stateless, just a wrapper around HTTP calls. Okay, so this is what our card service would be. And card store would be the one that contains the state and the one that all the components use. All right, so the first thing what we do is we declare an interface of what the state this service would be managing. And in this case, I just, for simplicity, just added the card items here. It could be many other things. It could be the loading state of the requests. It could be errors as well. So it could be a few more things. But usually they're very, very focused on a particular task. So here is card items I have. And card item array is, again, product ID to quantity interface. All right, so the next thing we do is we'll extend this component store and we'll provide that state that we just created, this interface, as something that it would be responsible for. The next thing what we can do is we can initialize it, or we can do it later, but here we'll just initialize it right away. So by default, it will be just like an empty array. So this is how we start creating it. Then we need a way to read the data from it. And again, we are reading in a very reactive way. So similar to card items that before, whenever things change, we would let everybody know. So now all the components can start listening to that and just subscribe to that, or async pipe with that. So for example, here's the card items. It just selects this card items from the state. And count does a little bit more. It takes that card items and reduces it to a single number, okay? So this is how we select. How would we update? Hold on, yeah, before. How would we use it? So we inject our card store. In this case, it's provided in root, so it's available everywhere. And again, we're just listening for this reactive property of card items count. Here it is. All right, so how would we update? The way we update is we create an updater. An updater takes a prescription of how, given the value, how it would change the state. So here it takes basically a callback of, okay, this is my current state, and this is the new value that you'll give it to me. And how would I change the state? In this case, I'll just overwrite the card items, but there could be other ways to do it, right? And what's interesting, set card items that it returns is now could be used as a function, right? So you see down below there, it's called with card items. Or another example is update status that's not implemented there. I could just pass a single value to it, right? So every time I pass the value, it would recalculate the state and save that state, and then all the selectors react to it. So this is how we read, this is how we write. And the final part, the most important part, I feel like, and the one that's typically overlooked with the service with the subject approach, is an effect. Let's break it down a little bit. So this one is the add product effect. And what it takes here is an observable of IDs. Why it takes an observable, we'll see in a second. But then it takes these IDs that are all being pushed into this effect. And here it can control that flow. So unlike the service that every time the method gets called, all the requests start in parallel, here I have a choice what to do, how to handle those race conditions, how to orchestrate this in a thoughtful way. So I'm not making this incidental complexity of just, oh, by the way, my race condition happened, or things just work because, just work. I have a choice here of one of the 4 operators. So for example, I got one ID in here, right? And I start making this request to the backend. So card service at product does this request. So what do I do when I get the new ID? Well, concat map says, okay, I'm still working on this one. Wait a second. When it's done, then I'll take care of the next one. But for some other requests, I might want to do like exhaust map. And exhaust map would say, okay, I'm already working on this. I don't need any new information. Or switch map, right? It says, hey, I have this new value. Now I cancel whatever I'm doing, and I'll use this new value. Or merge map. This is the default way how service with the subject behaves. Is I'll just start them in parallel. And if I'm modifying a specific values by index, maybe that's a way to do it. But sometimes we want to be a little bit of safer side. Well, the most important part here is we have to stop for a second and think about how exactly we want to do it. So we are basically prescribing the way how we would handle the new incoming values. I haven't seen a single application that tests for race conditions. There's not a single unit test that tests for race conditions. There's not a single integration test that tests for race conditions as well, at least that I've seen. So those are type of the issues that are pretty much just flow into the applications without developers even realizing them. Okay, so what do we do with this one here? So once we add the product and we have a result, here we call that updater. Remember, it would update the state. What's interesting is we're also asking people to handle the error here. So here I'll use another updater, which I didn't implement, but again, it's just one of the state. And we'll catch this error. Moreover, we have an operator to do these little part and all together and explicitly ask to handle the error. Okay. Error handling is a whole other topic because very frequently it's overlooked and people are staying with their infinite spinners and nobody's immune to this. And it's like, when taking the shortcuts or not using a prescriptive ways, that's what happens, right? Okay, so this is the way to handle this, and this is what effect is. How would we call this? Well, we would call this, or see, it takes the ID as observable, but the way we call it, we just provide a single ID to it. For example, see this add product, I'm providing a string, a single ID. And every time somebody else calls this add product anywhere in the application, they all basically go into this ID stream, and then this stream is where we handle how we treat the new incoming values. All right, so that's the effect. So in a nutshell, component store is an opinionated way to handle the state, and that's better replacement for a service with a behavior subject. So that's great, and we can sprinkle our application with component stores like this, and again, in most cases it would work well. However, sometimes we need a bigger state management solution, and component store, I don't know how many of you heard of component store because we just released it in August, so it might be still new and you could have been hearing it here for the first time. But the NGXS store solution has been around for some time and been also iterating and perfecting and improving and reducing the boilerplate or everything else from it. So where would we use NGXS store then, right? This application, this page, does a few things. Here we can see, you can probably see the difference in star color. The user might have rated already one of the products themselves. So if I rated a product, I don't want to see the average rating of whatever everybody else rated because I already rated it and I want to see it the way I rated it, right? I have already an opinion that I don't need other opinions in this. So that means this page, when it opens the product list page, it needs to do two things. It needs to first ask for the products themselves to display, but then also needs to ask for the customer ratings, right? So it does two things. Think of a bigger application. It might be doing 3 things, 4 things, and now we have, again, a little bit of a mess. So this interaction works, but NGXS store takes this interaction to another level. And instead of explicitly asking everything, give me this, give me this, give me this, it's transforming and saying, okay, I need I opened, right? Products opened, for example. Do the things, do whatever needs to be done. Let the system and effects and everybody else know that, hey, something needs to be done. This project, this component loads. And in return, it says, okay, give me the view model that I need for this component, and I'll just async pipe it into the template and be reactive. So testing this component becomes simple. This component is basically detached of what needs to be triggered happening under the hood. And then this product open is something that's called an action that is dispatched. And now the effects that are getting the customer rating will be triggered. The effects that are getting the products will be triggered. So multiple things can be triggered at the same time. And again, this is a toy. It's still kind of a toy example. So maybe you will be completely all right with a few component stores here trying to orchestrate things. But in a larger scale application, that becomes more and more important, especially when you have many other data and your effects depending on other things like router state, what's the current product is displayed that's taken from the URL. All of these things we're trying to remove from component. We're trying to make component as simple as possible, almost like React kind of nailed it, almost like a function that takes the data and produces this template, right? So this is what we want to be component to be. Then we can easily test it through the DOM, by the way. We can easily work with it. And again, hey, here's the data. You produce me the template, and it has this data in it. That's awesome. I click things. Those are being dispatched or calling other services. So it would be really, really easy and simple to, not easy, simple, but simpler to do. All right, so actions is the second level of the interaction. The first one was reactive, was a push-based approach, right? Sending a signal and reacting to this. NGXS store here also pushing notifications and reacting to this, but it's pushing the action notifications. So it's second abstraction. And the other benefits start to become more and more obvious as the complexity of the app grows, and the benefits become like compounding this effect, compounding. All right, so if you don't know, I don't know how many of you know how the store is structured or not. I can just do the quickly overview. Basically, store is a single source of truth. It's a single object. There are multiple reducers. Those are pieces that are each responsible for a specific slice of the store. Reducers are listening for those actions that we just saw dispatched, and they react to them and adjust those pieces. Components needs to dispatch an action. Right now, we saw the product page open action that was dispatched. We saw the selector. So this is how we react to changes from the store. And selectors are fantastic in this case because they can be listening to multiple parts of the store. They can be combining data, can be filtering data, and doing other things. So one other thing is not all actions are for a reducer. As I just said, some of them is to trigger effects. They do the network requests. We get the results back, and we trigger another action that could trigger other effects or reducers. And basically, this is the whole structure of the NGXS. And how does it compare to the component store, for example? Well, it also does exactly those three things: read, write, and side effects. We have create selector, create reducer, and create effects for that. How else is store different from the component store? In the NGXS store, the global state management, our create selector, create reducer, and create effects, they're all separate files. So if the state starts to grow, they become a lot easier to manage. But one thing I should clarify more and more, because people were saying, oh, NGXS, oh, the boilerplate, oh, many things. It shouldn't be used for all of the use cases, because it should, and you've heard it maybe multiple times as well, it should be really used for the shared state or where this complex interactions are needed, where multiple things get triggered, right? Because otherwise, we are trading the second drawback, second interaction of the action for nothing, right? We shouldn't be doing that. All right, so In the store, it scales really well as well, because again, those are all separate files, right? And we can create as many as we need. In the component store, there could be, it's a single file, right? So all our select, update, and effects are in a single file. And the way we do with the component store, we could create multiple component stores. But then again, their interaction could get complex. It has some additional stuff that we don't care right now. How else it compares? So again, NGXS store is a single object, right, that has multiple reducers. With the component store, we have multiple of them, and each one is responsible for its own part. All right, and also lifecycle. Even though we use component store right now with the provided in root, meaning it's a singleton, the typical usage of component store would be actually provided to a specific node in the component tree with the component level providers. And this is actually the recommended way to use it. Why do we need it? Well, once that component is destroyed, we would want to clean all that data. So it's no longer necessary. We can remove it and clean it up. The rest of the application is not interested to that. So whenever that branch is removed, it's gone. NGXS store, on the other hand, it basically lives through the lifetime of the application, and everything's shared through everything. So when I teach NGXS to people, I always say, think about it. Is it really needed for the entire application? If it's not, then maybe component store would be a better solution for you. So we have just 12 minutes. I'll skip this part because there's multiple use. Let me see. I'll just do this. So there are multiple use cases for the component store that are already clearly defined, and those are basically opinionated prescriptions how to handle things. I'm gonna skip the demo of them. I can show it later if somebody wants to see, but I'll get straight to the summary part right away. So Angular, I feel like, and again, this is my opinion, Angular is somewhat opinionated framework, and we're kind of missing the prescriptions for one of the most complex and intricate parts of how to write the applications. State management libraries like NGXS, actually it's two of them now, right? The different component store and the store, they help remove the incidental complexity. They help to address those race conditions heads on. They ask you to think about it. They ask you to think about how you handle errors as well, because it's part of the prescription, right? And they remove this incidental complexity that creeps in and try to organize it in a better way, try to be very prescriptive how you do things, trying to identify those patterns and apply those patterns in your application. Previously, NGXS was, and it continues to be, known for the global state management. And I felt that we were missing a piece for sure, right? There were a lot of use cases where people are coming up and saying, hey, how do I solve this with NGXS store? And a lot of times, like, well, there's no good solution for that, right? I feel like now NGXS is to the rescue, because both libraries, the component store and store, they are solving different problems, and together they can cover almost all the state use cases, state problems that most types of the applications face. So I think now we have a good story for all of it, and we're definitely embracing all of that in Firebase console. This are like thank yous for a few people. Kevin actually came up with the initial idea for the component store, for example. Brendan and Tim are my teammates in the NGXS world, so they help maintain the library and basically participate in a lot of design discussions, reviews, and things like that. Nicholas Jameson, core RxJS guy, he is also a fantastic help. I always bounce ideas off him. He's super knowledgeable. So, and also Lars from In-Depth. Also, I bounce off a lot of ideas, and then he's also very like in the architecture and has a lot of great ideas, part of the in-depth group. There are obviously docs for this, the Discord. By the way, there's also Angular Discord now, Discord GG Angular. If you want to see, there's a lot of great conversations there. Like Alex Rickavan maybe confirm or deny that. There's one for NGXS as well. And that's basically, thank you for listening.